Okay, so we have finished this also. So only one left here, Euclidean algorithm. So that is what we are going to do today. Okay, so what is Euclidean algorithm? Okay, Euclidean algorithm or Euclid's algorithm is an efficient method for computing the greatest common divisor, okay, of two integers, okay, where the largest number that divides them both without a remainder, also known as the highest common factor. That means GCD is also equals to HCF, highest common factor or greatest common divisor. They mean the same thing, okay? They are the same values, okay? So how are we going to find the greatest common divisor, okay? So Euclid's algorithm is used to find the greatest common factor. Greatest common factor, highest common factor, greatest common divisor, they all mean the same thing, same value. So how do we use? This is Euclid's algorithm. Algorithm means the steps, the steps that you use to implement something. So Euclid's algorithm here, we have 4 steps here. Step 1 is you divide the larger of the two numbers by the smaller one. Step 2, if there's a remainder, divide it into the divisor. And then step 3, you continue dividing the last divisor by the last remainder until the remainder is 0. And step 4, until 0. Step 4, the final divisor is the GCF of the original pairs of numbers. Okay, before we continue, we need to get some terms right. When you do division, what's inside here is known as? What's inside
So,
here?
madam,
Yes?
can we have the notes before you start this chapter?
No, you listen first. You listen
Oh,
first, then later I give you the notes.
okay, thank you, madam.
Okay. So now we are going to divide, right? Okay. When you do division, what is the number inside here called? This is not in the notes. Okay. What's the number inside here called?
Dividend.
Yes, dividend. What is the number outside here called?
Divisor. Divisor.
Divisor. Divisor. What's the answer here called? Answer? Quotient. Quotient. And whatever is left behind, if you have a sign here, this is called the remainder. Okay, so when you do division, this you need to know these 4 terms. The number inside is the dividend. The number that you divide with is called the divisor. The answer is the quotient, and whatever is left over after you divide is the remainder. Okay. Okay, now we are going to look at how to divide two numbers, how to find the GCD. Okay, we will come back to this example later. Okay, let's do some easy work first. Okay. Number 1, okay? Find the GCD of 12 and 13. Okay, GCD, greatest common divisor of 12 and 13. So you have two numbers here, 12 and 13. Which is the larger number?
30.
30. So we are going to put 30 inside here and 12 outside. Okay, we start with the larger number inside. So now we divide 30 by 12. How many times can 12 go into 30? 12 times?
2.
12 times 2 is 24, right? So what is the remainder? 6.
6.
Correct?
Yes.
Okay, now this divisor divided by the remainder. 12 divided by 6. 6 times 2 is 12. What do you get? 0. When you reach 0, you can stop. Okay? And the divisor for the last division, that is the answer. That means GCD of 12 and 30 is 6. Okay? Can you understand that?
Yes.
Okay, we'll go on to another example, okay? Next example, huh? So I'm writing a little bit different now. Huh? Find GCD, or this means find GCD of 123 and 36. So how do we start? Step 1, identify the larger number, divide it by the smaller number. So 36 and 123. How many times does 36 go into 123?
3.
3, yes. So 36 times 3 will give us
108.
108. Remainder is 15. Huh?
15.
So this remainder, so now this divisor, 36 divided by
15.
15. Yes. So 15 times 2, 30.
30.
So you have a remainder of 6.
6.
Now what do we do? We always take the last divisor. 36, go here 36. 15. So 15 divided by the remainder. So this is 12.
Oh.
Minus, you get 3. We still haven't reached 0. So now what do we do?
6.
Yeah, 6 divided by 3.
3.
6, 3 times 2, 6. So we have reached 0 already. So we stop now. Okay, we stop now. What is our answer?
3.
Yes, correct. So GCD for 123 and 36 is 3. Can understand?
Yes.
Okay, one more contour.
Sebab apa 3?
When you find the GCD of 524 and 524 and 148, okay? So bigger number is 524 divided by 148. So this is 148 times 3, yeah? Minus 444. So you have a balance of 80. So next division will be divisor goes inside here. 148 divided by
80.
80. Yes. How many times 80 goes inside here?
1.
1. So 80 minus, you get a remainder of 68. So we still have to continue. What goes inside here?
80 divided
80
by
by
68.
68. So 168. Remainder is 12. Still not 0 yet. So what goes inside here? 68.
68.
68 divided by 12. 12 times 5, 60. Okay, balance 8. So now
12 divided by 8.
12
12 divided by 8. 1, 8,
4.
4.
4.
So now 8 divided by 4.
2.
Okay, so they have reached 0. So now what is your GCD?
4.
Yes.
Oh.
GCD of 524 and 148 is equals to 4.
Equal to 4.
Can do? Okay. So this, we are doing it this way, long division. Repeatedly we are dividing until we reach 0. Or you can also write it in another way, okay? You can also write it like this. The first division is 524 divided by 148, correct? And we get, what do we get here? We get 148 multiplied by 3 plus 80. Is this correct? If I write like this, 524 divided by 148 is 3. This means 3 148 we have plus the remainder 80. Is this correct? Yes, isn't it? That means we have 3 of 148 inside 524 plus the remainder is 80. So what is the next line? Next line will be 148 divided by 80. 148 divided by 80 is 80,
80
1
times
plus
1 plus 68.
68. So what is the next line? 148, 80. So 148 divided by 80. 80, 68. So the next line will be 80
80,
divided by 68 is
68,
equals to 68 once
68
plus
plus 12.
12. The next line will be
68 divided by 12.
68 divided by 12 is equals to 12. How many
12.
times? 5 plus 8. Next line will be 12 divided by 8 is equals to, how many 8s you have? 1 plus
1,
the remainder is 4. Then 8 divided by 4 is equals to
2,
2 fours plus 0. So when you reach 0, you can stop. This is your answer, your GCD. Okay, so you can do it either this way or you can do it this way. For me, this way is much better. I see it very clearly like this, easier for me. Some people don't like to do this way, they like it this way. Okay, so you can use either method to do. Okay,
yes.
okay. Okay, this is for you to try, okay? This is question number 4, right? Okay, although it looks like big, huge numbers, but actually can be done quite fast, okay? Okay, you try this. So, anybody got the answer?
8.
8?
Yes.
Are you sure?
4,
4?
madam.
4? Okay, let's see. See, maybe missed something, okay? Okay. So we're going to start with 3084 divided by 1424. So this is 2 times, so we get 2848, correct? We have a remainder of 236. Okay. So now this divisor goes into the next one. Okay. Goes into here. So 1424 divided by the remainder through 36. We have 6. So 1460, remainder 8. So now 36. 36 divided by 8 is uh,
Whether it's true.
Betul.
Sorry, yeah.
226.
Yeah,
36 lah.
236. Sorry, yeah. Okay. 236 divided by 8, you have 29. So you have 232, you have remainder of 4. So 8 divided by 4 is 2, 8 is 0. So you have reached 0. So your answer is 4. Okay. Okay, good. All those are correct, good. Okay. Okay, so you have any questions for that? So far, okay? Yes? Okay, I take that as a yes.
Yes.
Okay. Okay. Someone need to try this, huh? Okay, so we have 8 questions here. First 3 students in the name list. Next 3, next 3, next 3, next 3. According to your name list and the last 4 students. Okay, so you each one do 1 question only. Now, okay, number 1, finished?
Six.
How much?
6,
6,
6,
Okay, number 2?
6,
Number 2 also 6?
Yes.
Number 3?
Number 26.
Number 3. Number 3. Anyone finish number 3? Number 4? Number 5? Number 6? Number 7?
Number
Number
6.
number 6 is what?
46.
46, okay.
Number
Number
3, 2.
2, okay. Number 1? Sorry, number 4? 5? 7? 8?
2, madam.
Which one?
Number 8.
How much? 2.
Yes.
Okay, 2. 7? Anybody? Number 4? Number 5? Okay, number 4 is 1, huh? If you got 1, all this is correct, okay? 46 and 2, huh? Number 4 is 1. Number 5? I think it's 23. Okay, you check the answer later, okay? 46, and this one is, number 7 is?
1.
Yes, number 7 is 1, huh? Correct. Okay, so if you can do this, then it's good, lah. All done already, yeah? Okay, so we have looked at how we can use Euclidean algorithm to find the GCD, greatest common divisor, which is also HCF. So earlier, in the last lecture, we found HCF using prime factorization and Venn diagram, okay? So you can also use this method to find HCF. So now you have 2 methods to find HCF. There's another purpose for Euclidean algorithm, okay? For example, if they ask you to reduce, okay, to reduce the fraction, okay, 861 over 984 to the lowest term. That means you want to write this in the most simple form, simplest form, okay? So this is quite a big fraction. How are we going to reduce this? You can try dividing by 2. You know that this number can, the denominator can be divided by 2, but the numerator cannot be divided by 2. So you have to keep trying with 2, 3, 4, 5, and so on, okay? Or the other way that you can reduce this fraction is to use the Euclidean algorithm, okay? Find the GCD for both the numbers and then you divide straight, okay? So what is the GCD for 984 and 861? Okay, so 984 divided by 861, okay? So this is 1's 861 minus, you get a remainder of 1, 2, 3. And then you have 861 divided by 1, 2, 3. This is 123 times 7 is 861. So there's no more remainder. Therefore, you know that the GCD for 984 and 861 is 123. This is the greatest common divisor. You want to divide these numbers by the greatest common divisor. Okay, so now to reduce the fraction, divide both numbers with 123 and you get, this is 7 over 8. So this is, now you have reduced the original fraction to its simplest form, 7 or 8. Very easily you have reduced. You don't have to go trial and error, or you don't have to try many steps, okay? So this is one very useful purpose for the Euclidean algorithm, to reduce fractions to its lowest terms, okay? Let's try one example. Okay, you reduce this to its simplest form using Euclidean algorithm. Try this, okay? Okay, finish?
Yes.
You finish both the questions?
Yes.
Okay, good. That's quite fast. Okay, what's your answer for this, for the first one?
15/14.
Yes, the first one is quite easy because you divide find the GCD quite fast, right? So 765 divided by 714. Okay, this is 1, so you got 51. So 714 divided by 51 is straight away 14. So you got 714, you got 0. So straight away you know that the GCD is 51. So 765, 714 divided by 51. Divide by 51, you get 15 over 14. And you must always write it back like this, okay? Okay, so this is quite easily done, so you can find the GCD quite fast. This one, what is your answer?
4356/4817.
Yes, correct. But to find the GCD was quite long. GCD is actually equals to
2.
2. So this number, although they are both even numbers, you look at it, you think you can divide by a bigger number, but when you do the GCD, you find that you cannot. So you have to go through quite a number of divisions to find the GCD, okay? So when you do this, you know for sure that you already find the greatest common factor. Then you know for sure that this one cannot be reduced anymore, okay? So this is a very good method. Euclidean's algorithm is a very good method to reduce any fraction, okay?